By the way, I know I'm lecturing a lot today. Tomorrow I'm going to have a couple of group work handouts that we're going to do. One of them is going to be based on this, the other one's going to be based on word problems. Oh yeah. Just to give you guys a little hint, this guy is only GCF. He won't go any further. Anytime you have a cubes, a trinomial might actually be the big dude, and the big dude's never factorable. So don't pull your hair out. And you can take a GCF out, right? And that's all you can do. All right, let me try to catch up to you guys here. And by the way, one way to do this kind of problem is to break it down into parts. And say that's problem number one. Let me just focus on that, and then put it back together and just kill what's common. So if your problem is bookkeeping with all this stuff, just break them apart and then bring them back together. Nothing wrong with that. So I won't do that right now. On the top there, what does that factor to be? Yeah, that was a thank God problem, right? On the bottom, what can you do? It will be eventually a sum of cubes, but
2 and x plus 5, x squared minus 5.
Oh yeah, let me catch up to you. So right there is what you get when you take a 2 out.
Yeah.
And the only thing the inside could be is a cubes, and 125 is a number you should probably know by now is 5 cubed. I like it. So we can do that on the next step. What can you do up here? Take out the 3.
Plus 25.
Good. And then down here?
X.
This is where people try to make this, they just write this down, they try, no. It won't work. It's missing a number, isn't it? So it's a GCF, that's all it is. Yeah, so X comes out. Alright, cool. So already I can go ahead and kill what?
X minus 5.
That's my fine. So I'm not done factoring though, so how do I factor this? I like it. So this is X, this is 5, 5, 5.
X plus 5.
X plus 5, I like it.
X squared.
And the other two X's? Good. Different sign, multiply whatever these are. And then the other two 5s. So what else cancels now? That guy canceled there. That guy cancels there. So who are my survivors? This is some of us have really big trouble with this. Right, of course, of me. Yeah, what's on the top?
3 over 1.
3. And what's on the bottom?
1 over
2. X. So on the top, the survivor is the 3. On the bottom, the 2 and the X survived. All right. Cool, I like it. And they keep going, they see the governor, and then they see the Michelle. She's in there somewhere. Sorry. All right, so again, it's all about factoring. If you can't factor, you can't do this at all. Yeah, okay. Just one more thing, and then I'll let us out of here a little early again. Maybe you can get a little used to that. We'll see. So this is involving the next thing you can do with fractions, which is adding and subtracting. And I know normally students, I don't care what level they're at. So my calculus 2 students, they're like, I really don't like fractions. So tears come out of my eyes. But what always got me is students who don't understand something like, if I did 1/4 times 9 halves, do I need an LCD? Hell no. The whole thing here is about reducing and stuff. In fact, if I had 1/4 plus 9 halves, do I need an LCD now? Hell yes. It's all about this. Can I multiply x times x squared? Of course you can. What do you get? X cubed. Can I add x and x squared? No. So addition is much more restrictive with how it determines like things, right? For multiplication, the bases just have to be like, for example. So here I can just multiply these together. I don't need like terms. But here I got 1/4 plus 9 halves. Well, shit, they're not like terms. I can't add those, right? So I only need like terms if I'm adding and subtracting. Multiplication is a little more lax, right? So does that make sense? Right there. Does that make sense? Does it make sense?
Yes.
Okay. Just pretend. So if I'm going to do this, what you got, Jeff? Let's do this. What can I do then? Yeah. Do they have LCD?
Yes.
Yes. So they're like terms. So I get 4x minus 2. And of course, what do I have to check now? Reduce. How do I reduce this correctly?
2x minus 1.
What about it?
You can pull a 2 out of it.
You can pull a 2 out. So what cancels?
2x minus 1.
So you just get 2. So think about that a little bit. This will freak you out a little tiny bit. No matter what x you pick, who can tell me what x cannot be? No, x can be 0 all day. I get -1. Who cares? The bottom can't be there's my 5th period. The bottom can't be 0. The bottom can't be 0. But what value of x makes the bottom 0? What minus 1 is 0? 1. How do you make 2 become 1? You cut it in. Okay, x can't be 1/2. I mean, do you see how to reason this out? Or you set equal to 0 and you solve for x, but you should be able to reason that out. So x can't be 1/2. But any other number you pick, all of this becomes 2. No matter what. If you pick 8, this becomes 2. If you pick 28.73, it becomes 2. If you pick square root of pi, the answer is 2. That'll freak you out a little tiny bit, maybe. But that's what we just proved. We just proved it. Does it depend on x? No, it's freaking 2. All right, that's one little thing. So if they're like denominators already, just slap them together. The last thing you got to do always is see if it reduces. So before I make unlike denominators, let me do this. This is the most common mistake in this kind of problem. Oh, get out of there, Jeff. Do your thing, Jeff. Okay, try to do that. See, my Math 90 students remember. My Math 90 students are like, stop pointing me out, man. Shit. This is the most common mistake. Let's see if you make it or not. So there's so many different ways to be careful. Whenever you have a negative in between two fractions, two rational expressions, you can't just say the answer is negative 2n minus 7. That's a mistake. So if you put that, I'm sorry. Thank you for playing. Because what's being subtracted is this whole damn thing. So that negative's got to go to both. It's got to distribute. It just doesn't look like it because. So one thing you could do is whenever you have a minus in here, is you can make it plus -1 in front of there. I mean, that just looks weird, but that's one way to do it. Or just remember, if there's a negative there, you just gotta distribute it. Because it is in front of this. Why do I not write parentheses? I don't need them because the bar kind of makes them together. I don't need the parentheses there to show that they're together. But then we're like, are those together? Yes, they are. So it would actually be 3m minus 5m plus 7, kick ass. So it'd be -2m plus 7 over 4m minus 5. Can you do anything there? Can't the 2 and the 4 go?
No.
Good. I like it because division cannot cancel parts of its addition or subtraction. It's not that powerful. Poor little dude, that's all I can do. That's it. So when you have a minus in the middle, just catch your brain and say, brain, slow the hell down. We got to do this correctly. Bring it through all the terms. Here, there's only a 2 there. We ain't going to make a mistake. There's only a -2. Ooh. So I'm not going to, here, there's 2 parts. Oh, shit. Okay, maybe. Yes, sir.
So all we did was we found like denominators and then we put all like terms together.
Yes, good. Just being careful, it's a minus in the middle to distribute that. I like it. Kick ass.
Question.
Yes.
Is there a reason we're not reducing the -2 and then the 20?
Yes. The reason I just gave, which is division cannot cancel parts of addition and subtraction. I really want that to make sense. So if I used to see this a lot, like 1/2 x equals 5/2, and then I have somebody do this. What did they do wrong? What did they do wrong specifically? What did they? Subtraction cannot cancel multiplication. So it works the other way too. Division can't cancel addition or subtraction, right? I mean, subtraction can't cancel division or multiplication. It's just they have to be opposite operations in order to cancel. So if I see this and this, I can't cancel parts of those. Now, if I saw this, I really want to make sure you guys are with me. If I saw this, yeah, there's a plus there, but it's a number divided by twice the number, so that number can cancel. Because it's times right there, right? So the part you're trying to kill has to be connected by times. But if I'm trying to kill a part that's connected by plus or minus, can't. Because division can't do that. That's the only reason. That's it. It's a very straightforward reason. All right. I feel like that's enough for today. What do you think?
Yes, do I.
So tomorrow I think I'll start with the handout that goes over what we did today. And then we'll talk about word problems and do some stuff there. Oh.
Are you starting homework?
You ready? There's got to be, so tomorrow there's going to be, you know what I'm about to say. First thing tomorrow is going to be a quiz on basically chapter 1 through 6. Mostly focused on factoring. Stuff you should know. Okay, cool. See you tomorrow. I'll send that out in the email I send out. So anytime you miss a quiz, the next test grade will also count for the quiz grade. So you just have to, the test will count a little bit more to cover you for the